All right. So thank you for everyone that's joining. My name is Kyle Shannon, and I will be talking through modern data stack for analytics engineering. This will be a brief overview of some tooling. There's a lot of tools that are existing in this space. So this is just more of a high-level introduction, encourage questions, and then at some point I'll do a little run through of DBT because I know that's one of the more popular tools that people are interested in. But feel free to ask questions, and we'll address them along the way. So the agenda generally is going to be talking about what and why for modern data stack and analytics engineering, kind of where we're at and what's causing this. Then we can talk a bit about extraction and loading, so how the data is actually getting from these source systems into something like a data warehouse, which would be the third one. Cloud data warehouses, we can generally talk about some of the top players there and how they're used. Transformation of that data, orchestration of using that data into different pieces, and then operating and observing on that data. So how you can then, from orchestration level, even have some third-party vendors that will allow to do this, manage services for you to move data around to different systems. And then how do you keep track of the quality itself? But before jumping fully into there, I'll introduce myself. For my background, so I have been a software engineer for over a decade now, working primarily in e-commerce, and then over the last 4 to 5 years, shifted more heavily into data and analytics. So building out a platform at a company called TeePublic. So it was an online marketplace for designers to be able to sell their art across the world. So as a engineer there, moving more into integrations and data itself, started to notice that we had a lot of questions. And starting with ad hoc analytics, you start getting more interested in how things are working and what's going on. And then moving really into building up the modern data stack as defined here for being able to serve the entire business, to understand all of their analytical needs, as well as being able to move that data around for operations like marketing and even for finance and all. So it's a very powerful way to interact with data, and it's very exciting. And I'm currently now at SeatGeek as a senior analytics engineer there, working to kind of understand all that is needed post a lot of this pandemic piece for a lot of events, which is really exciting, but helping to bridge kind of the gaps between data platform engineering and traditional analytics. So being able to add a technical side to analytics is what the analytics engineer is able to bring to the table. So what and why, and this is more just around the modern data stack itself. So people have probably heard a lot about it. Some quick little points to talk about of why this became more popular is there's been really like a very large increase in compute capabilities regarding around serverless. So previously in the past, people would have to have entire teams or have a data center or rent out boxes to be able to manage this scale of data that they're working with for their business. And really moving to this like cheaper compute capability, cheaper storage, and having things serverless, you kind of pay as you go for being able to work with the data, which made things much more affordable and much easier for any company of any size, small and medium, to get more involved, where traditionally it was larger companies that were kind of managing this. And then as well, the open source adoption for data projects. So a lot of really, really awesome projects have come out. I've mentioned DBT previously. There's a lot of different tooling like Amundsen for data observability. There's just so many across the board that we'll even touch on. Airflow is another popular one. But really, a lot of these tools became open source, which allowed for a lot of people to have more adoption and be more aware and start to actually evolve and create more amazing things within the data space itself, which started leading toward this like modern revolution of data in the stack itself. Volume of data, as everyone is probably familiar, we collect more and more data as time goes on. Previously more just transactional data, now we have a lot of event level data, and there's just so much more data being collected. So in order to use all that data and make sense of it, there needed to be more tooling that's being created around this, as well as data literacy across business users. So it used to previously just be more like analysts or someone in finance that's really like digging into Excel and working with data. But now you're seeing, the average project manager really leveraging a lot of these tools to understand how their products are working more easily. It's more accessible, and really just like the average user that's actually working, let's say, in sales outreach and all, really wants to understand the data and how they can improve things. Whereas previously it was more analysts really deep diving into the data. And then business value itself. So larger companies really were showing, Amazon talking about their A/B testing, Uber obviously talking about a lot of the different data work that they have, showing just the value that is allowed within utilizing your data and being able to leverage that data to understand how to improve your overall top line, as well as just improve different products and understand how to serve your users better. I think it's become more widely accepted and understood, as opposed to previously it was a little more black box and not really fully understood. So more and more companies are coming out talking about how they're getting value and impact, and also just it's a lower investment with a high return when you're leveraging these software as a service tools for the data. So previously, like I mentioned, you'd have to hire a whole data platform team, potentially have full compute boxes that are running. It's quite expensive and a lot of lift, whereas a lot of this is now pay for what you use. The average analyst can actually spin up a lot of these different pieces and work with software engineering as well to try and get value out of things. So it becomes more achievable in a smaller window of time to get going. So talking through some of the different pieces, extraction and loading. So what I mean by this is you're moving data from third-party source systems. It doesn't necessarily need to be a database. It can also be like CRM tooling. Salesforce is a very popular one. It could be your email service provider, customer data platforms. So really, traditionally, you had data platform teams that are writing a lot of this ETL. So data engineering really is doing a lot of this ETL work. There's a lot of common place for ETL to be moved from APIs. Ultimately, a lot of these different services are really just API endpoints that you're connecting with and moving this data over to the data warehouse or data lake, wherever it may be. It's a very solved problem and isn't necessarily the most fun one to work on as a data engineer. It's like, you wake up in the morning, you find out like an ETL failed, you have to try and see, maybe it's an API change, right? It's not the most interesting work, but it's something that's actually crucial and key to the business. So you can see here for paid and managed and open sourced. So paid and managed, the two that are popular ones are Stitch and Fivetran. So these, you ultimately would be paying for the amount of data or credits around the data that you're moving from these source systems. They have a collection of managed connectors that you can connect to. Let's say I'll be like just to a Postgres, to S3. You can do it as very simple to just databases if you want to, or Google Sheets, which is also a really fun one. All the way to your Zendesk for customer service, to Salesforce, to many different CRM and ESP and CDP tools to move your data around. They work with the APIs and develop and manage and maintain. So all you have to do is have a business user or someone that's tech savvy be able to go in, pick out what tables they want, replicate that table on a certain amount of time, and you'll get logs and monitoring around there. So this removes the idea of having to have the in-house ETL team. Of course, the downfalls are you don't have the capabilities of doing a fully custom ETL out of the box. So again, this can remove a good amount of effort, but it does not solve for every edge case. Fivetran and Stitch. So Stitch was actually built off the top of Singer. So you can see with the open sources over here. And then Fivetran's a closed source one, but they both have ways where you can actually create custom ETLs and leverage through the platforms. It's not the most intuitive and out of the box. You'd have to have engineering resources. But with the open source one, they're really leaning into that second part I'm saying, where you actually leverage your engineering to create these ETLs and leverage frameworks to make it easier to do it, right? So instead of writing your own custom code from scratch, working with the API, trying to understand everything that's happening, Singer, Meltano, and Airbyte really have all been big players, Airbyte being one of the newer ones, to really a framework and make it easier to move the data from these source systems into whatever sort of destination system you want. So with Meltano, it was managed by GitLab. They basically came in a bit after Singer. So like at this point, Airbyte is one of the newer ones. They're all very similar in creating frameworks. It really comes down to kind of your flavor and your style of how you want to do it. But it allows for testing and being able to connect and build these sources. The great part is these are open source. So as someone builds one of these connectors, the next person that needs it, it exists now, and they can contribute and help to build and make these stable. So it really leverages this open source community for everyone to start building more and more connectors and really drive a lot of value for things that people eventually need over time. So the cloud data warehouse. So when you're extracting that data, typically you're moving that to a cloud data warehouse. The three kind of big players here that are the names you see a lot are Redshift from Amazon, Google BigQuery, and Snowflake. They are what are called massive parallel processing data warehouses. So really, instead of the idea of doing more row-based transactions, these are more column-based and doing things in much more of a wide processing. A lot of companies would start with Redshift. It was one of the earlier ones. The reason why Redshift became really popular, it was relatively cheap. You can spin up clusters as you need it, and you have it running all the time. You're not paying per query. It's really just like you're paying for the nodes of compute and the storage that you have. So it's really, really friendly for kind of getting off the ground. One thing that they were struggling, which Snowflake came along and also BigQuery does too, is separating this idea of compute and storage, which also Amazon Redshift has already 3 nodes now to do. But really the size of data became really, really massive, right? So when it comes to running these machines and working with this large amount of data, the abstraction of compute became really popular with Snowflake and BigQuery. So you're actually just paying as a serverless style to query the data from whatever storage that you have, right? So you're ultimately abstracting this old idea of what like Hadoop was doing with big data and creating it as like a SQL wrapper that is fully managed as a service for what compute you need in order to transact and do all of this different what would be an old process that you would do Hadoop to aggregate and map reduce and break everything down. You can actually just write a SQL query and tell it how much resource to throw at it, and it'll magically do it, which is quite nice. So that's one of the biggest changes over the years of the ability for these cloud warehouses to manage that. And of course, being SQL standard, you can run SQL as you would as any analyst is familiar with as well, which is really great. Things to note for something like Snowflake, which is more cloud agnostic, is that you can actually leverage any of these clouds and have third-party connections. So you can actually query directly off of the Google Cloud Storage or Amazon S3 as well. So it's kind of playing the middle grounds of those, but depending on your use cases, things like Amazon, you can go fully into it using Glue and use a lot of their really nice tools to do a lot of the ETL built in, as well as with BigQuery, a lot of the Google marketing data can be moved around for free in data transfer to your BigQuery, which is a very nice thing to have when you're moving large amounts of data for business. And then going into the transformations, so I wanted to call out Dataform as well. So Dataform was purchased by Google a couple of years back. I don't have as much context, but I do know that they were solving for a pretty similar piece that DBT was doing as well, which is building a framework for basically taking a lot of this raw data that we talked about from moving from source systems. And traditionally it started with like, star schemas, Snowflake schemas, being able to really break down all this raw data into a more readable format for an analyst, right? So how does it make sense to do a couple joins instead of having join multiple different things and understanding the actual engineering systems? So with the DBT setup itself, which I'll talk about a little more, I'm more familiar. Think of it as the beauty of this open source, as we were talking about before. People are contributing. A lot of people are trying to solve the similar problems, but you're leveraging SQL and YAML on a Python framework, which is what DBT is built on, in order to kind of build all of your data models, run testing and documentation. So it became this centralized source, which makes it really easy to make value out of the data that we were extracting and loading on top of these data warehouses. So I'll do a little run through on that one in a little bit, but let's see. So I'll talk a little more on that. And orchestration. So after you're building these different data models, which I'll talk more, how do you then do some more complex jobs, right? So if you have different things that you want to execute on your data flow, say you created this model, an analyst looks at it in a BI tool, that's nice. But if you need to actually move this data to other systems maybe that don't exist through third parties that already handle it, or you need to extract some data from a system, clean it, translate it, do some different pieces to it, and put it into some sort of machine learning models. Airflow, Dagster, Prefect, these are very popular for DAG, dissected acyclical graphs. So you can basically build directed acyclical graphs. So you can build dependencies on these different jobs. So you can say, at the start, I want to hit this API, pull this data, and then drop this data into S3. And then the next task will go and grab that data from S3, translate it, maybe clean up some different pieces. And then a job after that, once it saves again, could then go and grab that data and create a DBT model inside your cloud data warehouse. And then ultimately you have another job down the line that is doing some sort of modeling and training. You can choose different resources you want on top of each of those steps and tasks. You can retry them. You can make it item potent so that you can actually retry these for previous days. So say you had to rerun a model from a months ago data, right? Because something happened in your search ranking and things started getting really bad, right? And you need to go back to what things were a month ago because you're seeing conversion rates go really poorly. Tools like this for orchestration will allow you to do that very easily and create a framework and structure around that. It also leverages a lot of engineering and data flow. So like with Dagster and Prefect, they're being more aware of the actual data that's moving through these orchestration jobs, whereas Airflow is just more or less trying to orchestrate it, but is a very popular tool for this. And operate and observe. So these are more newer into the space. Oops, I did not update this description. But operate and reserve for reverse ETL. This is supposed to be reverse ETL. Census and high touch are, and there's another one, Grouperoo, that I didn't add to here. What I was saying before is you ingest this data, you get it from, let's say, like a Stitcher 5-tran fully managed, right? You don't have engineers having to touch it. You bring it in, you have an analyst use DBT and build out these data models. They now live in your cloud data warehouse, but you're working with your marketing team, let's say, and you want to take that data model and move it into your CDP, right? So that your marketers can actually start to leverage this data. What ends up happening is moving that data would have been this previous slide and working with engineering of orchestrating to push this data to APIs, right? And still may exist if there isn't a pre-made connector. But there have been companies now that have understood the value in being able to do this all managed, right? So you can actually go through and have an analyst build all of this data modeling, work with a stakeholder like marketing, create what would be the CDP modeling, and actually use these tools to move that data into the CDP or into the CRMs and have it be fully end-to-end managed solution where only the data modeling is being owned by the analyst, right? So this is like really, really valuable if you don't have any engineering resources. There are certain companies, of course, that don't even have that ability. So this is like a road to actually getting to an end goal without even having to hire that in-house engineering team to be able to support it all. And then, you know, a big question that comes from that, of course, is like, if you are doing all of this and you don't have that engineering team to understand the data quality or things that are happening here, to observe and make sure that you have quality here. There's a lot of players that have come up more recently too, like Monte Carlo, which will do more of end-to-end observability. So you can see all the way from your data ingestion to the reports that are being surfaced in your BI tool, and know where something may have gone wrong along the way, so that you can start to troubleshoot more quickly and be able to fix those parts. Databan worked more in the orchestration layer. So this adds the visibility for the engineering side, particularly in very complex like orchestration logic to understand what's happening along the way and monitor and log things in a more clean and defined fashion. And then with Datafold, they have a tool that's really interesting, and they even have an integration with dbt where if you're changing a model, they will actually do a data diff on this. So say you're making an update to some sort of attribution or some sort of ranking, and you can actually see what previously changed to this model on a PR request. So like, they allow for that. They do some anomaly detection and monitoring as well. That's all built in. But basically, it allows not to have engineering resources and allow for that analyst to get visibility and understand how to fix and maintain things along the way. So there's a lot of really exciting tools. I kind of blew through a quick bit of this. Before I go to questions, I will see if I can share my actual desktop and run through a little DBT. But I'll pause there for any questions first.
Yeah, we have a couple of questions, so let me quickly check. So yeah, there is one question from Bayram is, are there extraction tools that connect to your own mobile apps, websites directly and bring the data to your data warehouse?
That's a good question. Ultimately, they would go through usually a database. You can set up things to have be like, you can go off like a webhook, right? For example, so say maybe your mobile app or anything else has a webhook that is set up, you could actually be webhooking that data. So like automatic, like passing through the API directly, and it'll land over into the data warehouse with those tools.
Okay, thank you. No, we don't have any more questions.
Cool. So real quickly, can you see the terminal screen?
No, not really. I mean, I see that there are some,
yeah,
there is something
gotcha.
tiny.
Okay, cool. So we'll make that larger.
Yeah, that works.
So this is an example of the DBT demo project, which is called Jaffle Shop. So I've already cloned this down. I just wanted to kind of show generally what the folder structure and things look like within DBT. And then run a few commands to just high level talk about what is going on with DBT. So DBT is a command line tool that essentially lets you use SQL to build all your models, but you can then write tests in YAML, like I mentioned before. So opening into the actual project itself for Jaffle Shop inside this VS Code, walking through at a high level, you have this data folder, which you can do what are called seeds. So essentially, if you have like CSV files or anything that you wanted to upload as static data that is not changing often, you can leverage it within this framework. So for this project, all of the data is coming from seeds. So they're using a raw customer table, an orders table, and a raw payments table. There are many DBT modules you can install. I won't go into that, but there's a lot of different things you can use that are kind of plugins, if you will. And then the models themselves, you can go through and create in SQL. So talking about this raw data here, if you look at customers, we have an ID, a first name, a last name here. And then in this staging customers, we are going through and normally I'd set it for them here. So they're selecting all the raw customer here. And then what they're going through is like renaming ID to customer ID and grabbing that from the source and dropping it in here. This is very lightweight transformations. It's really just aliasing from that raw data. Similarly for the orders, it's going to do that as well too, changing ID to order ID. These are useful for analytical, right? So when you're actually joining and working as an analyst, you know clearly you're working with an order ID, not just like ID itself. So very lightweight pieces here. And then the final output from the staging is you're looking at customers, you're then joining all of your staging customer data, all of your order data, and all your payment data, pulling together in some CTEs real quick here to grab like when was the first order this person placed, what was the most recent order, how many orders did they have, and then pulling in data as well of like what's the total amount of payments they've made. And it allows you to kind of join all this together as a final and pull in basically a customer's table that gives you this like lifetime value, first order, most recent. So building out a model for the customer itself off of that raw table, the raw CSV data. Orders will be doing very similar. You can see here there is some Jinja coding. What's also really helpful in DBT is you can actually use Jinja to do kind of lightweight programming for loops and setting arrays and different data that you want in here to check payment methods to make sure they align with what's actually expected in here or where it's supposed to be in a case when. And ultimately, this will then build your models using the DBT command line in your cloud data warehouse, how you set it up for the configurations. So I have a little Snowflake like free trial instance set up. But what I will show first is if I were to run DBT seed, this is going to go through that data folder that I had talked about with the CSV files. And it's actually going to take all the CSVs and load them in as actual tables in this DBT schema that I had created for it. So all of this is now going to exist in my, where's my Snowflake? So if I go into this Jaffle Shop now and go and look at my public, oops, 1 second, let me go back over to here. So basically running this setup here is going to then create those tables for that raw customer. And before I run that one, so that's just going to do a seed for this on the DBT side. If I go through and then do a DBT run, what this is going to end up doing is it's going to take those raw tables and run this transformation logic that we defined for customers and orders. So it runs and builds all of the dependencies as well. So it has a dependency understanding for how the references are running. So it'll build all of these staging tables first, which then can be reused in other final tables as well. And really what it's doing is you can see it's telling when it's starting off the run for creating those models. And then it's going to give you success or failure if it hits any errors along the way and tell you just like how long it actually took. So this is really just running queries that are compiled that I'll show in a minute. And then lastly, which I'll show what this actually looks like, is with testing, you can go through and actually test all of your data inside DBT to understand what is going on. So you'll see this command line output that's happening here. What this is doing is it's actually running, if I go into my tests, models, schema. So inside my actual folder here, there is schema. And inside this schema file, this is where you're doing your definition in YAML, which is quite easy and nice to work with and read. So looking at this model of customers, I can then describe what this model actually means. So this table has basic information about a customer as well as derived facts from customers' orders. And then within here, on each of those different fields and columns that I'm building, I say this column name of customer ID, here's a description, unique identifier. I want it to be unique and not null. And essentially what ends up happening from this is if we look into this target folder, which every time you're running anything in DBT, it will create out a target folder. It is going to show us what is being built. 1 second. Actually in the schema, okay. So it'll actually show you everything that's being compiled and built in the SQL itself outside of what you're doing in DBT itself. So like when we write that test to say, I want the customer ID to not be null, it's actually running this query against the database and making sure that the results come back with no rows so that you actually do have no, you do not have any null customer IDs. And then same thing here for more detailed one, where you're looking through and you're actually checking on the orders and you want to make sure that the status of those orders, right, is actually placed, shipped, completed, returned pending, or returned. Now they seem kind of minor to some degree, but when you're working within the data and you're actually making decisions and reporting and trying to understand what what the values are within all of this, you can then be very confident and make sure that when you're providing any data out in the cloud data warehouse, after you model it, that what you're expecting in those values are actually true and that you're not actually putting through nulls, whereas some downstream applications may end up grabbing some bad data ultimately or cause some sort of issues in some sort of modeling, or reports are broken, and this will be all able to be shown in this actual test when it's running. So you can set that up. Oops, 1 second, sorry. Just on another device. Sorry about that. I apologize. My little 1-year-old is having a music class, and it decided to join on our speaker here. So that was that's the beauty of running live. So before I keep going on that, I know I'm kind of digging a little bit deeper. I want to pause again for any potential questions on anything related to the DBT side or just generally on the overall stack.
So I have one question and there is another question. So I didn't quite get what model is in DBT lingua. Like, what does it mean to have a model? Is it description of data or what?
Yeah, so the model is ultimately like, there's a couple different ways to define what levels of the models they are and what it is, but you can think of model as actually the output of the data. So typically you can do it as ephemeral. So you can do it if it's just like you want to create, that's a good question. So if you want to go through and say, I have this staging customer. So each of these would essentially be a model that you're building in, right? So inside the models, each file and output of the name of it are going to be considered models. And you have multiple ways to actually define how those models are handled by DBT. And they have configurations where you can say, I want it to be ephemeral. So essentially anything that's depending on it will just be a CTE to use it. You can make it be a table. Obviously, it'll actually materialize to a real table. Or you can make it be like a materialized view or even a view itself. So really the models are more or less the namespacing of what you have here. And the way the models kind of typically build out are the base and raw data, and then a staging where you're doing some cleansing and joining to be able to put it in. And then these would be your kind of like facts and dimensions, depending on how you're doing the actual modeling for it.
And what is CTE?
CTE is a common table expression. So you'll see it like this with statement here, right? So you're, it's kind of like subqueries. It's just like a different way of doing subqueries that makes it more readable. So instead of saying from this, you're actually saying with this alias, and then you're able to query it here.
And internally, does it translate to a bunch of like creates a temporary table somewhere, or not really? It executes the whole thing.
Yeah, so it'll either, depending on how you set it up. So like if you do the ephemerals, it'll actually just create, depending on the driver too, like some databases will do temporary tables. Some will actually just put them directly in the CTE as a like namespaced CTE for the table, aliasing it. Or you can actually, of course, materialize it to an actual table if you want more performance on it as well.
Okay,
Depends
so
really on like what data you're working with.
okay, now it made sense what you said. Like you basically repeated the same thing you said at the beginning,
Yeah.
but now it made sense to me.
Yeah, it's a little like it's interesting because like it is somewhat simple, but it also is quite complex, and the
Mhm,
ability of understanding all of the moving parts, right? And like when to optimize and like, when things should be a materialized view, when things should be a table, how to keep it ephemeral. And the very nice piece of DBT as the framework is you get to just write it all how you would normally, and then you get to define that separately in logic and
mhm.
configuration, which makes your life a lot easier.
Okay, so now nobody stops you from copy pasting this query and then putting this to BigQuery or Snowflake or Redshift, right? Because this is like apart from some Jinja code that I saw, this is plain
Mhm.
SQL that should work, right?
Yeah, yeah, and even if you wanted to use the actual query and dump it in, like I mentioned before, the target file will actually take the compiled. So you can just do like dbt compile if you don't want it to run against your warehouse. You can just do dbt compile, and it'll just write the SQL in how it would be and copy paste that out as well. So
Yeah,
you can
so
even use it as like a translation engine if you really wanted to, and just like write your own stuff, not even build it, and like just use that for the queries that you're writing, right?
yeah, because there is a question from Amit is like, why do you need DBT if you can just copy paste these queries to your
Yeah. I think
database?
the value of something like the DBT side is when I was mentioning before, which I should probably dig a little further on, is really the testing and documentation side is really useful. So let me pop that open again real quick. Okay. So one of the really, really valuable pieces, at least I learned over the years of using DBT, is you're working on data models, you have these queries you're throwing around, maybe you're creating table from those different queries and doing all that. But I was stuck in a world without using this where you're working with stakeholders and there's data quality issues or questions or concerns around different pieces. You end up having to kind of create your own way of validating a lot of this. So you're like writing those, okay, is my customer ID like fanning? Is everything unique? Is it not null? Like what's actually happening here? You tend to do that every time you're debugging or looking into things, right? So the beauty of using the DBT framework is you can actually set up all these tests, and every time the data models are run, you can have these tests go through. And then on top of that, the documentation as well. So you can see here how this one actually does not have the description part for it. But if we go into the schema, um, all the descriptions and everything are set here, and you can get all of this documentation pushed into your data warehouse as well if you want to. You can do more complex testing like relationships and way more. You can even write your own tests because really all these tests are one-off SQL queries. So the value of the DBT framework for making sure you use this is like being able to say, I want to actually run all these different tests and document and make sure all these relations to all the things that I just built work. Versus if you were writing that and creating your own tables, it's going to be very difficult to manage and maintain. And there's probably going to be like a lot of redundancy that you won't even be aware of.
Yeah, and you also mentioned, I think it figures out the dependencies and in which order you want to run this. And in your demo, I saw that it was actually executing these queries in parallel, so that there was like number of threads were 4,
Yep.
I think. So
Yeah. So you can set those threads. Yeah.
it was able to figure out like in which order it should be executed, right? And then which things could actually run in parallel, right? And then
Yep.
do that. That's cool.
Yeah. So actually, there's another beautiful part is the DBT docs. So I will generate that and then just serve this as well. So talking about the dependency, with the documentation that they have, this will actually give you a view into like the raw data that you have here, also the models themselves. And then you can go into each of the pieces that are built here under models. But if you look at this lineage graph, you can then very nicely see that my customers table is now created off of these 3 raw tables that move into these staging tables that eventually fall into what this customer is. So this gives you really, really nice visuals in order to be able to like trace that. And this reference that you're talking about here for the threads and running is all understood because you're using references to the models as they build and knowing what is related to what.
So basically, you don't need to specify explicitly what should run after what. You just based on names, it can figure that out, right? Like
Yep. So
in Airflow,
yeah.
you need to explicitly say that, okay, this task depends on that task. And then based on that, it figures out the order, right? But here it just
Yep.
automatically knows that, right?
Yeah, for this one, as long as you're using, so this is where again, using the Jinja and the framework itself, as long as you're referencing what model is supposed to be run off this, DBT will actually build out, if anyone wants to like look at really um, fun things in general, there's a manifest in here somewhere. Maybe it didn't build out, but it'll actually dump all of this information into JSON as well for what is the dependencies, which is what it's using for how this is all built out. So it essentially creates an understanding, like you said, of references and state, as long as you follow the framework of referencing here or putting sources in certain other areas as well too. So being able to reference all those parts gives it that lineage and understanding, and then essentially can give you the breakdown. And then if you wanted to, you can go in and see the documentation. It'll give you, you can add tags to different things here. It tells you what kind of owner, relationship, the approximate size, when it was last modified, row count. And then in here, you can see this is where all the testing and documentation is, and how it's referenced by other models as well too. And then when we said before of the Jinja versus compiled, you can actually see all this in here as well. So it gives a lot of information for being able to go through. And if you wanted to do that query directly to your database, you can do that here by just copying it. But it will give you visibility into how things are going. I think long term, what'll be really exciting is when you can get column level lineage, right? Right now, it's all just like what the models are referencing, but like how to see where customer ID kind of flows through. And that's something that's probably in the works as well. So, but it gives you a lot of ease and understanding. And then if you're just into one model, you can see what was related right here in this lineage graph too.
Does it have any scalability problems? Like, let's say if you need to run 100 queries, 1,000 queries, when does it stop working?
Yeah, so it all just comes back to your warehouse, right? Because all it's doing is very lightweight SQL commands. So the cool part with DBT and Snowflake that I'm more familiar too is like if you have some models that are small, you can actually configure that model to say like run on a small machine, and say you have like a really heavy processing that's doing something very complex. You can actually say like, hey, I want this to run on a more powerful machine as well. So with the framework, you also get the complexity of kind of automating a lot of that stuff if you were to do it manually. So you can create this and it becomes documentation, understanding and living, right? So it's like really nice. You get to see why and what's going on, but also anyone can configure it very easily. So very easy to use.
And let's say you have multiple queries that are not related. So let's say you have multiple projects, right? So one can be about marketing, the other can be about I don't know, something else, payments or whatever. So do you put it all in one repo within one DBT, or you have like multiple repos? How do you?
Yeah, so it's always a fun question, right? It depends like on where those dependencies and crossovers are, right? It's similar what they're saying for like data marts, right? Like, because you have this one area that is like fully for marketing, let's say, and then something that's for like finance. There's always going to be crossover and redundancies. So I think it really comes down to how much crossover and how interdependent they really are, because you don't necessarily want to like rebuild too much, but you also don't want it all in within one like massive project. So there are ways to actually reference another project within the same project. It gets a little more complex, but like you could, in theory, say, I want to make sure that this one is done, but that's where the orchestration layer of like Airflow or Dagster or Prefect or something is going to be more useful, because they'll be able to talk outside of just that one uniform of DBT.
Okay, yeah, that's actually a good segue, because a question from Luke is, what are some use cases on using both DBT and Airflow? And I guess you just mentioned one.
Yeah, that's the one. If you're doing the interdependencies, another, like I said before, is like if you are doing some sort of like machine learning, like training and all, you could leverage DBT to do your modeling for you and do your data cleansing, and that's just one part of your orchestration pipeline. So you could even use like an example, right? With Fivetran, they have an API to ingest this data. So like you could use, let's say in an Airflow job, ping Fivetran to like pull this data in. and then leverage DBT to then check the source and freshness of that, model it, then have that be passed downstream to something that's actually pulling all of that data into dumped out into like S3, let's say, or even using an unload and then using it there. So DBT can be one part of the step. It's really on the transformation side is really the heavy lifting that it does. And that's where these other orchestrators will become more useful.
Mm-hmm. And are there any challenging when using both DBT and Dataform?
So they're plugins. There's different ways to like handle it. It becomes a little more complex because you're basically introducing another tool, like any other style of it. But you can actually run like DBT directly within Airflow if you wanted to. Or you can do it with like DBT Cloud, which is another offering they have to use like APIs to run things. So it really depends, I think, on the project that you're working on. There can be complexity, but there also can be simplicity depending on how it's kind of architected together.
Mm-hmm. Okay, thanks. So I don't see any more questions. So just a reminder, if you want to ask a question, there is a link in the live chat. Click on this and ask. And yeah, maybe I'll ask you a couple questions that I have. So one,
Sure.
like how, like, let's say there are you showed us many different tools, right? So for example, in the beginning, what was the first step? Ingestion, right? So it was like there are paid tools like Fivetran and Stitcher, right? And then there are open
Stitch,
source
yep.
like Stitch, yeah. And then there are open source like Airbyte. I don't remember others. Like, how do you decide? Like, do you want to, use open source one or
Yeah.
use this managed one? Like, is there any
Yeah,
rule of thumb?
I think it's a great question, right? Because it really depends. So typically, if you're trying to get business value immediately and you don't have engineering resource, you would probably lean toward like Stitch and or Fivetran, right? Because depending on what connector it is, if it's something that's a common connector, the lowest friction is going to be proof of concept to have that fully managed, right? But usually as you kind of scale out, if you're in some sort of business where you can't use third parties to do this data transfer, right? Like there's some sort of compliancy or you have to do things in-house, you're definitely going to have to build on top of these open source frameworks. So I would say really like security and privacy is one of the major concerns for some of where to go initially, as well as just resourcing for engineering and the ability to be able to invest in that time of it, right? Because there'll be an upfront investment on something like an Airbyte versus and maintenance that'll have to go on versus something that's just like fully maintained. Longer term, having a team, if you already have it, to maintain something like the Airbyte one probably makes the most sense. But again, it can be a hybrid version as well too, where like some of these connectors are already fully managed that way, which takes a heavy load off of some of it, and then they can focus on other areas as well.
So if you use something like Fivetran, the data actually goes through Fivetran, right? So they first maybe make a call to your, I don't know, whatever CRM or so they get the data, it goes through Fivetran and then ends up in your warehouse, right?
Yeah, I know there's definitely like security and compliances they have around that. I wouldn't be able to speak too specific to it, depending on which data, but yeah, like ultimately it's going to have to be somewhere temporarily before it lands over. I don't think they actually like read or have any access to it by any means, but there always becomes an issue where there's any data landing anywhere, right? So, so if there are really, really strict concerns, then you're going to want to probably own that. Yeah.
Okay.
Adding to, yeah.
I think am I audible? Can you hear me? I'm not sure if it's my connection problems for you. Like you're fine.
No, I can hear you. Yep. Yeah. Some of the other parts that I'll add that are interesting with like the kind of more modern cloud data warehousing, right? So one thing that was like a really cool, interesting use case that I had previously was we at Tiva like we were AWS like shop, right? Everything's on AWS, and then we were acquired by someone who was a Google shop, right? And if you have those two worlds, it's kind of relatively difficult to talk to them, right? But with something like the Snowflake setup that was quite nice and making things really easy was being able to actually point and target directly and ingest and dump data into something like a GCS bucket with configurations and just setting up keys within Snowflake. It seems kind of simple, but like really it's a huge lift of having to remove a lot of different complexity, right? So like being able to actually say to even a third-party vendor, let's say, right? Say they're in Google Cloud and they dump the data daily into this GCS bucket, right? They don't have to now bring it into your Amazon S3 bucket, or you don't have to maintain how that gets there and all. You could actually just set up a connection with them, go grab that. And even if you had to give data back to them, let's say, you can dump that back in there as well too. So it creates this really nice like cross-cloud collaboration for being able to move data back and forth, which traditionally would have been, let's say, like an orchestration with an Airflow that says, I need to go get this data from them, dump it over into my internal service, do some calculations, drop it back in my internal, but then also push it over to theirs, right? Like ends up taking 6 steps and moves it into like 1 or 2. So those are some also interesting kind of more newer use cases for things. And then talking more on the observability, I think that's a really popular topic right now. So it's really nice that you have an analyst that can do, let's say, all this end-to-end modeling, right? And then move all this data, let's say, into a CRM. But it is also very useful to have engineering practices in place for some of this. It's you're paying as you use the query compute. It can be some inefficient queries potentially running and costing more. So like all these positive cases are really nice, but you can then also end up at the end of the month where you have like a $100,000 compute bill from BigQuery or Snowflake because the queries that you're running are super inefficient, or you're dumping data every hour that you don't need to, right? So there always is like trade-offs and understanding. So as these tools become very easy to work with and very simple to do, the idea when I was talking about observability is just being able to understand like, okay, well, what exactly is going on behind the scenes here? What is the actual quality that I'm using of this data to move over to these different systems, right? So that's becoming a more popular topic of things get accelerated really quickly, and now it's like, okay, let's make sure we're focused on doing it correctly and making sure everything has good quality for where we're pushing it, because we're starting to take actions on a lot of it.
Do you know any open source observability tools? Like, because I don't know, I think the 3 you mentioned, they are managed, right? They are closed source.
So Databand, I believe, is open source. Okay. Databand should be open sourced. I think there may be some others. Again, like there's a lot in this space. I wouldn't consider myself an expert on it, but I do know Databand is open source, and you can integrate that as well. Yeah, there was actually an interesting post recently that talked about like, how can you do your entire data stack open source? Because it's now to this point where like, you could actually open source your data warehouse. You could open source all your ingestion. You can open source all your transformation, like your observability, your like all the orchestration, right? So like at the end of the day, you could really just own all of this completely open sourced, which is really interesting. So in a world that previously was like more vendor focused.
So what would be open source warehouses? Because Redshift is closed source, right?
I think ClickHouse was one.
Sorry, which one?
ClickHouse is
ClickHouse.
a popular,
Right, from
Yandex, it's a popular open source, yeah. And then even on the BI layers, which I haven't really touched on in this one, but like the BI layer tooling for business intelligence reporting. So like very popular tools that everyone is using is like Looker, Mode, Tableau, right? To look into a lot of this. But then you also have these open source tools like Metabase. Another one that was interesting is called like Lightdash, which is like an open source Looker style for how things are going. So you're just seeing more and more interesting, innovative projects coming along in the data space, especially in the open source world, because then they have an idea, they start getting traction, and build a community, and then ultimately turns into like a paid service to manage it, which is kind of interesting. But it's like a more the approach is better for the community, right? Because everyone is actually involved in what needs to be done versus a vendor really trying to say like, this is how it should be done.
Yeah, exactly. Do you know what tick stack is? TICK. Does it?
No, I don't know that one.
So there is a question about this. If the tick stack can be used for observability, maybe you can Sancharam, maybe you can write what tick stands for. So it's also first time I hear that.
Yeah, I haven't heard that one either. Yeah.
No, it's.
I thought it was referencing TikTok, but.
That's quite interesting that you mentioned now that everything can be open source, and that what is even more interesting that some companies choose this way of working is through like open sourcing.
Yep.
So, my kid is suggesting to switch rooms, so he wants to play in this room.
Nice.
So how's so you said your daughter is having some dance classes right now?
Oh yeah, so my son is like 1, and
Sorry.
it's okay. He's basically doing like an online music class today, so
Okay.
it's kind of hilarious. But I just like how the speaker comes over, the old working from home, right?
Yeah. So I don't see any clarification what tick stack is, so we can. So
Yeah.
tick is telegraph, InfluxDB, chronograph, and capacitator. So to me, I don't. Sorry.
Yeah. I'm not sure. Those those are a little bit more probably outside of my understanding for it. You probably could, yeah, those are probably more niche. I feel like there probably are some tools around that, or at least some sort of open source projects that are probably leaning into that area, but I don't know any off the top of my head, unfortunately.
Yeah, that's I think this maybe like for traditional observability, like for usual DevOps stuff, not for data.
Yeah.
Well, I think I've heard this InfluxDB as a time
Yep.
series database.
Yeah. Yeah.
Yeah,
Influx is another one.
yeah, so TickStack is a platform composed of open source components with which make connection, storage, graphing, and alerting on time series data, such as metrics and events, easy. So, yeah, cool.
Interesting. I'll have to check it out.
Okay, well, do you have any last words before we finish?
No, I just think it's really exciting, and talking back to like the modern data stack for analytics engineering and what that means, right? So like these are all newer terms, right? A data engineer in some cases has been doing analytics engineering, and analytics engineering is doing data engineering, right? Like it's very much dependent on where people are needed in certain parts of the company, or where the company's data maturity is in. I would just encourage people to learn more and see more of what's going on. But my biggest lesson that I had working in data engineering and analytics engineering that I would like to share is most important, understand the data and the business and why the data is important. I think sometimes it gets easy to get caught up in tools and fun things, or, coding challenge or different things. But at the end of the day, the data has value based on how the data is being used, right? So that'll be like my PSA. Happy to discuss any more of these different tools in more detail. I know it's a lot of very high level tools to talk about, but feel free to reach out to me on Slack on Data Talks. And yeah, appreciate you having me on. It's a lot of fun.
Yeah, thanks. I was going to ask you how can people find you, but I think you just answered. Are you also on Twitter and LinkedIn?
Yep, not too heavily, but yeah, you can find me on LinkedIn. It should be in my Data Talks profile as well. Twitter, not so much, but
Okay.
see, someone's ready to play. Yeah,
Yeah,
time for
he's
you to do some
exactly. Yeah. Okay, thanks for finding time to share your knowledge with us. And yeah, I guess I need to run now. So
yeah, definitely
it was
enjoy.
nice
Have fun.
chatting with you, and thanks everyone for joining and for asking questions. So have a great day.
Thank you.